Okay, welcome to science. Um, Going back a little bit so that we start our conversation on significant digits over again. It's been a few days off, and I don't want to jump to the hard part before we talk about the easy part again. Okay? So it's just a quick refresher. I'm going to go through these super fast. Most of you have this in your notes already. If the digit's not a zero, it's automatically significant. No question about it. Okay? 341, I count to 341. I ignore these leading zeros. I'm going to call this three significant figures. Okay? And all these problems are pretty straightforward. 345 milliliters. Just count the number of numbers that are not zero, and you're all good. Okay? Now, it's going to get tricky. Because we've got to talk about when zero is significant. The easiest zeros that are significant is if it's a sandwiched zero. A sandwiched zero comes in between two numbers that aren't zero. So 205 has a sandwiched zero. And we can say that there are three significant figures. And this part, again, pretty straightforward. 1, 2 sandwich zeros, and a 5. It's got four significant figures. 3.05 sandwich 0, you got three sig figs. 10004, decimal point there. We got three sandwich zeros, an 8 and a 4, five significant digits. This part's really simple. Again, I will always ignore leading zeros. Okay? Leading zeros will never, ever, ever be significant. Never will the zeros that come in front of a number like 0.0205 ever be significant. Okay? You could have 1,000 of them and they don't matter. 5.024 or 5.025 times 10 to the 4, four significant digits. Okay? 2.008, four significant digits. Now comes the tricky part, the terminating zeros. So remember I said leading zeros will never, ever, ever be significant digits. Okay? They're easy to throw away. Terminating zeros, sometimes yes, sometimes no. And this is going to be the hard part for people because the rest of it's pretty straightforward, right? If it's not a zero, it's significant. If it's a sandwich zero, it's significant. If it's a leading zero, it's irrelevant. The only thing that you have to really think about is a terminating zero. The big factor you want to look for with a terminating zero is whether or not there is a decimal place. The decimal sign is present, it's going to be significant. If the decimal place is absent, the decimal sign is absent, it is not a significant digit. 100 grams, no decimal place, one significant digit. 100 with a decimal place grams, three significant digits. So no decimal place, I don't count the terminating zeros. Decimal place, I count the terminating zeros. 0.005, one significant digit. Leading zeros will never, ever, ever matter. Okay? Leading zeros don't matter. Terminating zeros may matter. It depends on whether there's a decimal place or not. 0.00100. 0.00, these are leading zeros. I can ignore them. There's my decimal place. 100 are all going to be significant. 220.80. What do you think that one has? Well, go through. We know 2 and 8 are significant. 0 is sandwiched between 2 and 8, so it's significant. There's my decimal point that has 4 significant digits. Do a few more of these. 3.20 times 10 to the 2. It's probably in your best interests to convert here. That'd be 320. There is a decimal place right there. We're going to call that 3 significant digits. 104.3024. Both of these are sandwiched zeros. I'm going to call that 7 significant digits. Here we got some leading zeros. We don't care about those guys. 94700, however, all matter. There's my decimal place. 5. 400. No decimal place. How many significant digits does that have, you think? 400 with no decimal place is just 1 significant digit. And probably the trickiest. 7.0 times 10 to the 4th. What do you think this one has? This is the trickiest. That should be up and for you. I highly recommend that you notice number 1, there's a decimal place. Number 2, if you expand this out, there's actually 4 terminating zeros. So this actually has 5 significant digits. J is probably the hardest problem there is as far as this goes. Okay? So, rules for calculating with significant digits. Addition, subtraction. Answers must be rounded to match the measurement with the least number of decimal places. So if I had 1.1 milliliters and I added 3 milliliters and I added 16.25 milliliters, the first thing you do is you calculate it normally. 1.1 plus 3 is 4.1. 4.1 added to that 16.25. It's going to give me 20.35. Okay? Line up your decimal places. Make sure you add correctly. Addition of decimals is going to happen a lot in science this year. But now you have a new step. So this is where the math problem ends. And now a science problem begins. You don't want to report more significance than your least number of, or than your least significant digit. So in addition, subtraction, you're looking at decimal places. I see this one has 1 decimal place, no decimal places, 2 decimal places. I'm going to end up reporting this as 20. Okay? You're looking at the least number of decimal places will determine the decimal places of the number you report. Okay? That's really important if you're using a stopwatch. So your stopwatch on your iPhones is probably going to be much more significant than, say, the meter stick. Okay? Significant digits for multiplication division. Your answers must be rounded to match the measurement with the least number of significant digits. Okay? Notice previously we were talking about decimal places, right? Addition and subtraction, what matters is how many decimal places does a number have. Multiplication division is about significant digits. So you have to be able to count significant digits to correctly answer a multiplication or division problem in science. So 2.2 times 1.63, well, 2.2 times 1.63 is 3.586. Okay? Now you got to go back and you got to look at your decimal places. This for significant figures. This one has 2. This one has 3. You got 2 significant digit figures here, 3 significant figures here. So you're going to have 2 significant figures in your final answer. 3.586 rounds up to 3.6. The big difference really is in addition, subtraction. You can line up all your places very easily, and you won't have any errors from that. Whereas if you're multiplying, depending upon how big of a number you multiply by, you'll have either really long decimals, you can have a lot of numbers up front. So you're looking at the overall significant figures when you multiply divide. Otherwise, you'll report that it's a better measurement or a worse measurement than it actually is. So let's give this a practice. Here we got 6.14 plus 5.6. So again, I'd line these guys up. 6.14, 5.6, 4 comes down, 6 plus 1 is 7, 5 plus 6 is 11, this is 11.74. Now I'm going to apply the science piece. It's addition, subtraction. I'm looking at decimal places. This says 2. This says 1. So that's 11.7. You always go with the least. 6.14 milliliters times 5.6 milliliters. 6.14 times 5.6. You go through your multiplication. Again, I'm totally fine with us doing calculators in science. The science is the important piece. Excel and C programming are both excellent calculators. So yes, totally use a calculator. But now we got to this point, we know it's 34.384. If that were the math problem, we're done. It's a science problem, so we got to go back. We got to say, here's 2 significant figures. Here's 3 significant figures. My answer has to have 2 significant figures, so I'm going to report 34 milliliters. 2,548 grams divided by 0.01 grams. Alright, if you divide it by 0.01, you're really just moving the decimal place over by 2. That's 254,800 grams. I got to go back. How many significant figures are here? How many significant figures are here? Do those leading zeros matter? They don't. Make sure you leave off the decimal place. If you put a decimal here, you'd be saying that all these zeros mattered. So do not put a decimal place on that number. You have 1 significant digit. Look how high it rounds up. So 254,800 in this case rounded up to 300,000 because it has a single significant figure. Okay? 43,010 plus 92.4010. Remember, I got a decimal point here. That 0 is significant. That 0 is not. Let's add these on up. 43,010 plus 92.4010 gives you 43,102.4010. It's addition, subtraction, though. What really matters in addition, subtraction is decimal places. This has 4, this has none. The answer is 43,100. .9 milliliters minus 0.001 milliliters. Well, 0.9 minus 0.001 is 0.899. This has 1 decimal place. This has 3 decimal places. Answer should have 1 decimal place. That's pretty much it. I've got a worksheet for you guys to practice this a bit more on. Tomorrow we're going to look at graphs. And then I've got an interesting reading debate thing for us to do with the metric system. So go ahead and practice on the handout that should be coming out to you now. If you finish that in class, you're done. Work on homework for either math or Mr. August's class. Otherwise, we'll see you back here tomorrow. Have a good one. Bye.